All right, welcome everyone. This is a tutorial for lesson 1.8 to help you with the lab report. I'm going to go over all the documents that you need to have open and how you need to use Excel, or you can even graph by hand, but I'm going to go over the Excel method today so that you can enter your graph and complete your lab report. So let's take a look. This is the first document that you need. It's called Lab 1.08 to submit. So this is the document that you're actually going to enter all your information into and turn in. You'll also need the lab data, which is called Lab 1.08 data. It's a PDF document. It has a couple charts in it. It has this one with density of the rocks, or it has information that you'll use to calculate density. And then it has the melting rate of two different rock models. So first is a conglomerate rock model, and the second is just a plain block of ice. Let me show you in the lesson. So if you go into my class notebook, or if you go into lesson 1.8 in the online school, this is the information that you're going to see. So it walks you through it, and it even has a video where it shows you what they're doing. But what they've done is just taken a bunch of kind of pebbles or stones and then added water and frozen that into a solid block. And so this is what they're calling a conglomerate rock model. So it is sort of a model of, a larger type of rock that we're going to look at later in the trimester. But it is going to have a different density than if you just had a plain block of ice of the same volume. So that's what we're comparing today. This with stones inside versus just a plain block of ice. We're going to look at the rate and see if they melt differently. And that actually brings us to the first question in the lab report, which is your hypothesis. So it says, write a hypothesis that describes how you think the rock model with stones will break down. And you can say whatever you believe here. Do you think that it will break down faster or slower if there are stones inside of that block of ice? Or do you think it won't have any effect at all? And that's what you can enter in here for your hypothesis. You're going to come back to the hypothesis down here for number 2. So don't worry so much about your answer there. We will get to it again here. Number 1, this is the first graded question. It's worth 5 points. It says, show how you determined the density for each rock model and then tell which one is denser. So here is the mass and volume data. You are given that. So I'm going to open the data document back up. You're given the mass and given the volume for both rock models. You need to calculate density. Notice that density's units are grams per centimeter cubed, and you are already given grams and centimeters cubed. So all you need to do is add in this operation of division. So let's go ahead and enter the data, and then we'll do the calculation. So 420 and 226, I'm going to enter that in here. And then let me go back and see, it was 229 and 234. And then to get that answer, you just need to divide the two numbers. And so that is going to give you a number that's pretty close to 1.9 if you're rounding. You don't need to give me more than 1 or 2 decimal places. So something like 1.9. And it's always good to follow up with units, because units tell us what information we're talking about here. So this is a density of 1.9 grams per cubic centimeter. And then when we divide out these two numbers, 229 divided by 234, we get a number that's pretty close to 1. And again, our units are grams per cubic centimeter. Okay. Number 2 says, do you think the density of the ice affected the melting rate of the ice, or do you think adding the objects affected the melting rates? Be sure to include data to support your answer. So in this question, you want to address that the conglomerate rock, the one with the stones in it, has a greater density. It is almost twice as dense as the plain ice rock model. And so you want to say, do you think that one is going to affect the way it melts? Again, you can go back up to your hypothesis and say, I think they're going to melt exactly the same. I don't think it's going to make a difference whatsoever. You can say, I think the density is going to make it melt quicker. I think it's going to make it melt more slowly. As long as you reference that one is more dense than the other, and that you have a reason why you think one is going to melt faster or slower, or you might say that it doesn't matter at all. you'll earn 3 points credit for question number 2. Okay, number 3 is where we need to do some of the graphing. It says, show your data for the melting rate of the conglomerate model and of the plane model. Then on a separate sheet of paper, graph your data. You don't need to insert the tables because you're given that. So when it says show your data, I really want to see it in graph form. You can do it by hand on a separate sheet of paper, or you may turn in a picture of your curve or insert a picture if you're using spreadsheet software. I really recommend using Microsoft Excel. It's a good way to become comfortable with using this type of product, and we're going to use graphing tools a lot throughout science courses. Okay, so what we need to do is take this data and put it into an Excel spreadsheet. Unfortunately, the best way to do that is going to be by hand, and to save time, I have already done it for you. So I'm going to bring my spreadsheet over here, but I'm going to pull it down here so you can kind of see what happened. So I made 3 columns. I made one here that says time, and I show the units, which are minutes. And so I went from 5 all the way down to 150, because for the ice model, the time goes down to 150. And then I entered the mass for the conglomerate and for the plain ice or the plain rock models into 2 separate columns. So for the conglomerate rock model, I just went through and copied all of this information here into the second column. For the plain rock model, I scrolled down here. I started at 210, and I copied all of the data here into the spreadsheet. So I'm going to close this data document. We don't really need it going forward because now we have what we need here. So working in this spreadsheet, now we need to turn this information into a graph. In the lesson on Wednesday, we went over the way that we take a look at independent and dependent variables. I'm going to go back here just to show that to you. So here, the title of our graph is going to be melting rate of rock models. So we're looking at 2 different rock models, and we're going to be exploring their melting rates. But we need to decide what's going to be on the x-axis and what's going to be on the y-axis. The x-axis is always our independent variable. It's what the experimenter is manipulating or testing. In this case, we're just looking at time. So we're looking at the melting rate over time, and time is going to be our x-axis data. The thing that's being measured is the thing that is our dependent variable. So we are measuring the mass of the rocks. Now, in this case, we didn't measure it. We're just taking the data that someone else did the experiment from, but we're going to use mass data as our y-axis information. That's going to help us when we ask Excel to create the graph. So in order to create a graph in Excel, it does most of the work for you. You just need to highlight this information. Make sure that you have it set up in this way so that time is your first column, conglomerate rock is your next, and plain rock follows that. You can switch them up, but it might add an extra step in here. I've gone up to Insert in the toolbar, and I'm going to insert a chart. I'm going to pick this drop-down menu, and the specific type of chart that I would like to pick is a scatter plot. And so you see, as soon as I hover over scatter plot, I already have that showing up in the spreadsheet. So I'm going to pick this scatter plot, but now we just need to make some modifications. If for some reason your chart doesn't show up like this right away, then you would click here and switch row and column, and it will alter that for you. But if you have your spreadsheet set up in the same way that I do, then you should have your chart pop up right away. So this looks really nice. We've got 2 series. Series 2 is our plain rock model, so we see how the plain ice melts. Series 1 is our conglomerate rock model. We see that it kind of starts to melt the same as the first one, but then it kind of drops off. So it seems to melt quicker at the end, whereas the ice maintains a consistent melting rate over the whole time period. Okay, so it looks like we're good to go there. We're going to change the chart title. And so we want it to be descriptive. Melting rate of rates of rock models. Perfect. And then we want to add in And I'm going to use this plus sign here. And I'm going to say add axis titles. That's going to give us an X and a Y axis title. So I'm going to change this to time, and our units are minutes. And then over here for our Y axis title, the units for both are mass in grams. And you can see that the first conglomerate rock model starts around 420 grams and it goes down to 0, whereas the other one starts around just over 200 grams, and again it goes down to 0. In order to get this, and you can even change we can play around with this and get it to change the series titles. Don't even need those. We could say that in the document when we add it in. But let's copy this. So I'm going to copy the chart. I'm going to take it back to our lab document, and I'm going to paste it in. And there we go. So number 3 is answered. You could put a legend down here. So series 1 and series 2. Oh, sorry. It's the plain rock model. Okay, and that's all you need to answer number 2. Number 3. Number 4, it says describe how your graph shows how the ice melted over time in terms of your curve. So it's asking about these two curved lines. How did your hypothesis and the true melting curve compare? Would you write a different hypothesis now? So this answer is going to be different depending on what your original hypothesis is, but you have to give me a description of these two lines. So you would say something like the conglomerate rock model and plain model started with lines that look about parallel, but the plain rock model melted at a fairly consistent rate over the entire course of the experiment, whereas the conglomerate rock model had a steeper curve. At some point, it started to melt faster than the plain rock model. As long as you give me information about how that relates back to your hypothesis, so you can say whether or not that was in agreement with your original hypothesis. If you give me some information there, you'll earn full points for number 4. And that's all you need. So save that information, save your document here, and upload it to the online classroom. And I'll grade it as soon as I get a chance. Let me know if you have any questions. I'm happy to help. Keep up the great work, and have a great rest of the day.